We are back with section 12.2 on tree structure. Hopefully you got the section review questions done of the previous section, and hopefully you're ready to talk about some tree structure today. Let's talk about roots. Very important part of the tree. Two different kinds. There's a taproot, which is a main large root, and a spreading root, which there's many main large roots. So if you dig up let's say a live oak tree, you're going to find out that it has one large, massive root. If you dig up a palm tree, however, you see that those roots go in all different directions. I'm going to take a break because I'm ordering Chipotle. I am back. Anyways, we're talking about spreading roots being a part of palm trees. So the roots spread out. Sometimes even roots are found in really weird parts of the plant. So here you have some mangrove trees native here to Florida, and they have roots coming all out of their stems. Kind of strange. And these roots, well, not only do they collect water, but their actual main purpose is to support the tree and how it stands in the water. Very strange. Sometimes you have roots coming from the top of the tree, and those are called adventitious roots. Just strange, unexpected root region. You also have, oops, it skipped a page. The main stem of a tree is called the trunk. The trunk has several layers, 4 of which. It's got the bark, the cambium, or vascular cambium, the wood, and the pith. Obviously, the bark protects the tree. It's the outer layer. The vascular cambium grows the tree in diameter, a process called secondary growth. And so you see a tree gets larger in its width each year, or at least it should. And this is called secondary growth. Primary growth is when you grow up. Secondary growth is when you grow out. Trees have to do both. The wood is made of dead cells used to transport water. So if you have wood beams in your house, which I would think you would have, it's a bunch of dead tree cells. Isn't that strange? But anyway, every time the wood grows, it expands a layer which causes growth in the annual growth rings. We're going to take a look at these annual growth rings here. I'm going to include some of these on the test. Not anything super complex. But we can make some inferences based on these annual growth rings. Check out this spot here. You see how much the space is between these rings? That means the wood grew a whole bunch. That means there must have been some really good weather for the tree. But you see how little the tree grew during these years? The rings are very close together. That means there must have been some serious drought, some serious bad weather. Here you see the wood actually got burnt, so we can inference that there was a fire. And we can also inference how this growth is really, really narrow. There's not a lot of growth being done. It's probably because insects wanted to eat parts of the tree and prevented its growth. So even just by taking a look at this tree, we can find out clues about the past. We can even see how old this tree is by counting the rings. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say maybe this tree is 30 or 40 years old. Some of these trees are thousands of years old. In fact, we have a tree in California, I believe, a forest that is about 3,000 years old. That's pretty crazy. That tree was around when Jesus walked the earth. Amazing, right? Oh, I'm getting a call. All right. I'm going to pause the video. I love the sound that Skype makes, that do-do-do. It's kind of cool. I hope you're enjoying checking in with me in the morning. I see some of you, and I feel like I learn more about you because I can see your house, and it's maybe some of your siblings show up, and they're like, "Hey, I got a call from the Mendezes, and Daniel and Diego were in the background like this." They were kind of cool. But anyway, let's move on. Sturdy stem continued. The pith, we talked about the pith as the central core, which contains the cells that are alive. The pith dies, though, over time, and it becomes what's called the heartwood. Unfortunately, the heartwood is the wood that was once alive that is now dead. What a name, heartwood. It sounds like it should be alive, heart, but it is not. Sapwood is what is still alive. It is the functional part of the pith. Trees, of course, have branches. We know this. Branches branch into twigs. At the end of the twig is a bud. This bud allows the stem to grow and to produce new branches, flowers, and leaves. Specifically, the terminal bud, or the bud that is at the very end, is the one that allows for growth. Crazy about leaves. Leaves vary by location because they want the best access to space, sunlight, water, and minerals to grow. They compete against each other. So maybe you have Tom the tree, and Tom's slightly taller than Tyler. Well, Tom the tree is going to get more sunlight than Tyler the tree will. That makes sense. You have the cuticle. It's a waxy layer on top of a leaf. You ever take a leaf and you kind of play with it and it feels kind of waxy. The cuticle protects it from losing any water. There's also different types of leaves. You have shade leaves and sun leaves. Shade leaves are as broad as possible because sun doesn't really catch the bottom of a tree all that often, but the top of the tree it does. That's why the sun leaves are very thick. They can do a lot of photosynthesis at once, but they don't have to be broad because they don't have to have a big surface area to catch the sun. Hopefully, if you're at the very top of the tree, you're going to catch all the sun just because the tree's tall. Trees preparing for winter. Now, around here in Florida, trees don't prepare for winter all that much. But I, of course, come from Pennsylvania and New Jersey, and you can see the trees preparing for winter. The days get shorter, the nights get longer, less light reaches the leaves, and at some point the tree just decides it's harder for me to do photosynthesis than it has been the entire year. I'm going to shut things down because it's costing me more time and energy to stay open to photosynthesis than it is just to close up. And at a certain point, what's called an abscission layer, it cuts off the leaf and allows the leaf to fall into the ground. Chlorophyll, which is the main green pigment in the leaf, no longer gets produced because the sun makes the chlorophyll really shine out. And the other pigments within the leaf, the purples, the reds, the blues, those come out. And those all have different names. Your textbook talks about them. Carotene turns it orange. Anthocyanin turns it blue. Big names of these different pigments. You don't need to know them. Anyway, on the plant that just lost its leaf, it resides a scar, so the plant doesn't accidentally lose any of the sugars, because the leaf has to come off of a branch at some point, and if there's a hole in that branch, it can leak out the sugar that it worked for, and that's not very good. Here is a beautiful picture. This is one of the things I miss the most about living up in Pennsylvania, is the fact that sometime in September, October, the leaves start to change color and fall from the trees, and you can scoop up all those leaves and make them into a giant pile, and you can jump in the leaf pile, and that's a lot of fun. But it is quite beautiful. But its beauty in death, all these leaves are about to fall off and die. And that's the end of section 12.2. And tomorrow we're going to talk about forests and forestry. Make sure you do those section review questions, 12.2, page 444, numbers 1 through 7, as well as the thought provoker. We're going to make you think, so watch out. Anyways, we're signing off. I hope that you are staying safe and enjoy these video lectures.